Alright, this is your final review, numbers 32, 33, and 34. We're going to use the law of sines to find the missing side of a triangle. We need to find the measurement of AB given the measure of angle A is 55 degrees, the measure of angle B is 44, and little b is 68. For reference as to what they're talking about, let's start by drawing a triangle. If I draw my triangle, we have big A, big B, and big C. We are trying to, well, let's put in what we know first. We know this is 55 degrees. We know B is 44. We also know that across from B we have little b, across from C we have little c, and across from A we have little a. They tell me that little b is 68, and they want me to find AB, which is really just C. Now, when I do the law of sines, I need to do like little a divided by sine of A equals little b divided by the sine of big B, which equals little c divided by the sine of big C. So I need two sides and two angles, essentially, across from each other. But really, I notice right now I have my b's. They both have numbers across from each other. That's awesome. So I'm going to use little b over sine of big B. But I need to find little c over here. So it's all going to have to equal little c divided by the sine of big C. Now, I don't know what big C is, but I can find it because notice we have 1, 2 angles, and we are a triangle, so we can find the third. Remember, if I do 55 plus 44 plus angle C, it should all equal 180. So we are going to go ahead and solve that so we can use big C in our equation. I'm just going to make this smaller so I have more room. When I do 55 plus 44, I get 99. So we have 99 plus angle C equals 180. We're going to subtract 99 from both sides. And when I do that, I get angle C equals 81. So this part here is 81. And we're going to plug everything we know into this formula here. So I know that little b is 68 divided by the sine of big B, which is 44. And all of that equals little c, which is 80, or excuse me, little c is what we're looking for, divided by the sine of big C, which is 81. We're going to solve this equation by cross-multiplying and solving for c. So I'm going to do 68 times the sine of 81 equals c times the sine of 44. We need to get c by itself, so I'm going to divide both sides by the sine of 44. And that is what we're going to type into our calculator. I'm going to zoom out again just so I can have a little more space. At this point, you have canceled out your sines, so you're left with c equals 68 sine of 81 divided by sine of 44. We're going to type that into a calculator, so I'm going to do 68 sine of 81. I'm going to type the top and hit enter, and then divided by that answer, sine of 44. When I do that, I get 98.684. We would round down so we can just cross that number off, and we have 98.68. Or excuse me, sorry, I'm saying the wrong numbers, but my calculator says the right ones. It should be 96.68. I wrote the wrong thing down, which would be B. B should be your final answer. 33 says the same thing. Use the law of sines to find the missing angle of the triangle. Again, I'm going to start by drawing my triangle so I know what I have and I know what I need to find. We have A, B, C, little a, little b. They tell me that little c is 48. They tell me that little a is 34. And the measure of big A is 41. And they want us to find big C. This is great because we have these two that are across from each other. So we're going to use little a over sine of big A equals, and then we have these two that are across from each other. And we're only missing 1, which is good because it means we can actually solve it. So we're going to do little c over sine of big C. I know that little a is 34 divided by the sine of 41. All of that is going to equal 48, which is little c, divided by the sine of big C, which is what we're trying to find. Again, just like the last problem, we're going to cross multiply. So I'm going to do 48 times the sine of 41. And we're going to do equals 34 sine of big C. Now we're trying to get rid of 34 so we can get sine of C all by itself. So I'm going to go ahead and divide both sides by 34. When I do that, I'm left with sine of C equals 48 sine of 41 divided by 34. And we need to undo our, oops, sorry, I didn't mean to draw on it. We need to undo our sine because we need to get C by itself. So to do that, we're going to do the inverse sine. So we're going to do C equals sine -1 of 48 sine 41 all divided by 34. Now this is something that I would type into my graphing calculator. The one thing I want you to be careful of is I would make sure that this is in parentheses. It already puts the first parenthesis for you. Make sure you close it. And if you want to be doubly safe, I don't know if you have to do this, but you can just put the top in an extra set. But I think you'd be fine if you don't do it. So we're going to do second sine of 48 sine 41. Make sure you close your parenthesis after the 41 divided by 34. When I do that, I get 67.85, which is going to be 67.9, which is D. I actually tried it without the green parentheses, and you don't need those. So just make sure that you do the blue ones around 41 and you're good to go. The last one says use the law of cosines to find the missing angle. Remember, your law of cosines is something like a squared equals b squared plus c squared minus 2bc times the cosine of big A. I'm going to draw a triangle so we can see what we have so far and what we're looking for. They say our triangle is J, K, L, which means we have little k, little l, little j. We know that little k equals 9. We know that little l equals 9.75. And we're trying to find angle J. So we're looking for this angle here. If you want, label your corners. So maybe let's call JA, we'll call KB, and we'll call this one C. So then we have little b, little c, and a little a. And you can go ahead and just use your formula. Sorry, I missed a label when I was drawing things in. Little j is 12, so little a is going to be 12. We're going to plug in everything we know. We're looking for big A, so that variable is going to stay in my equation, but everything else is going to get replaced. I'm just going to zoom now so I have more room because this equation is kind of long. So we're going to plug in little a, which is 12. So I have 12 squared equals b squared, which is 9 squared, plus c squared, which is 9.75 squared, minus 2 times 9 times 9.75, and this is all times the cosine of big A. We're going to simplify. 12 squared gives me 144. It equals 81, which is 9 squared, plus 9.75 squared, which is, I'm going to round, so we're going to call it 95.1, minus, and I'm going to do 2 times 9 times 9.75. That gives me 175.5 cosine of A. Now, I can put these front things together, but I have to leave this guy all by itself because it has that cosine of A attached. So I'm going to do 81 plus 95.1. When I do that, I get 176.1, so I have 144 equals 176.1 minus 175.5 cosine of big A. And I want to get cosine of A by itself. That is my goal. We want to get this guy alone. So we're going to start by subtracting 176.1 from both sides. And I'm going to zoom again. When I do that, we do 144 minus 176.1. We get a negative number, negative 32.1. And it equals negative 175.5 cosine of big A. We need to move that 175.5 because again we are trying to get this alone. So we're going to divide both sides by negative 175.5. Divide by negative 175.5. When I do that, I'm just going to leave, I'm just going to leave my fraction on the other side, and we're just going to set equal to cosine of A. So I'm going to have cosine of A equals 32 negative 0.1 divided by negative 175.5. Notice they both have a negative, so it turns into a positive. We're trying to undo our cosine, so we're going to do A equals cos negative 1 of 32.1 divided by 175.5. And then you're going to type in your calculator. So we have 32.1 divided by 175.5. I already typed in my inverse cosine. When I do that, I get A equals 79.4. We're going to round to the nearest degree, so we just want 79, which looks like it is answer D. Way up there, all teeny tiny because I zoomed out. But that is your law of cosines.